let's look at how rescaling and shifting a data set works. Consider, for example, that you can calculate the score of an SAT using the scores from the ACT. So this is for two standardized tests, Test A and Test B. And you can get the scores of Test A by knowing just the scores of Test B. So for the scores of Test B, you just multiply them by 50 and add 20. So we're shifting the data set by 200 and rescaling it by exactly 50. So we're given the summary statistics for those who took Test B, and we want to figure out what the summary statistics are for those with the equivalent scores in Test A. Before we do that, let's remember that the measures of position are affected both by multiplication, division, as well as addition and subtraction. So measures of position are affected by both of these constants, whereas measures of spread are only affected by multiplication and division, and this addition is not going to affect any of our measures of spread. So things like the lowest, the median, the mean, Q3, those are all measures of position and will be affected by both the 50 and the 200. Whereas measures of spread, the standard deviation and the IQR, those will only be affected by this multiplication of 50. So let's look at an example of how this might work. These are the summary statistics for Test B, and we want to know what the lowest score for Test A might be. So we can take the lowest score for Test B and plug that into our formula for both the multiplication of 50 and the addition of 200. So because the lowest score is a measure of position, we can multiply that by both 50 and add the 200. So we can do both rescaling and shifting of the data, and that's going to mean that the lowest score for Test A is 1100. Let's try another question that tests for the measure of position. This time, let's focus on the mean. The mean is also a measure of position, trying to look at the center of the data set. So for Test B, the average score was 26. And again, this is a measure of position, so that's going to be affected by both multiplication and the shifting parameter of 200. So the mean or average score for Test A is going to be 26 times 50 plus the constant of 200, which gives us an average test score for Test A of 1500. Now let's look at how measures of spread change under this relationship. Remember that measures of spread are only affected by multiplication and division. They're not affected by addition and subtraction of a constant. So to find the standard deviation, which is a measure of spread for Test A, we can take the standard deviation for Test B and just multiply it by 50. We will ignore this addition or any subtraction of constants, and so the standard deviation of Test A is just going to be 250. So let's try a few other problems. Here, this problem looks at the third quartile for Test A. Now the third quartile for Test B is given to us. It's 30, and this is a measure of position. It's where 75% of the data falls below. And we can find the third quartile for Test A by both multiplying 50 and adding 200 to that third quartile for Test B. That's going to give us a Q3 of 1700 for Test A. Again, this is a measure of position, so it's affected by constants that are added or subtracted, multiplied or divided. The median is also a measure of position. It's where the middle point of the data set is. So again, it's going to be affected by multiplication and division of a constant or addition and subtraction of a constant. So we can find the median for Test A by multiplying by 50 and adding 200 to the median of Test B. Now I want to point out that the median and the mean are both measures of center. But here, they're two different numbers, and it's fine for them to be two different numbers because they're calculated differently. The median, again, is that middle data point, where the mean is the average of the data. If they're different, then that means our data set is skewed, and because the mean is lower than the median, this data set is going to be skewed to the left. The last question wants to calculate the IQR for Test A. Remember, the IQR is a measure of spread, So it's only going to be affected by multiplication and division. It's again not going to be affected by addition or subtraction of a constant. So to find the IQR for test A, we can take the IQR for test B and multiply by 50. Again, we're going to ignore this addition of 200 because shifting doesn't affect measures of spread. So that's how shifting and rescaling works. Remember, when we're calculating z-scores, that's what we're doing. We're shifting the data set so it's centered around the mean of 0, and we're rescaling it so that the standard deviation of these z-scores is exactly 1. And this is going to allow us to use the normal model and makes all kinds of interpretations in terms of probabilities. We'll go over how the z-scores are used in the next video.